to. So let's start. An auto cycle is conducted as follows. So before you can even put the data, draw the sketch of both a PV diagram as well as a TS diagram, which is not that important, but it's for you to be able to refer and check if your answers do make sense. Right, so let me draw both sketches. The auto cycle PV diagram as well as the TS diagram. Temperature entropy diagram, and then we said auto cycle has so we have one compression, heat addition, expansion, and heat rejection. So this is a PV gamma because it's adiabatic. PV gamma is equal to C. Even here we have PV gamma is equal to C. So two adiabatics and two constant volume processes. This is our PV diagram. The TS diagram, we have 1, we have 2, you have 3, you have 4. So the maximum temperature in a cycle here is T3, according to the sketch. So an auto cycle is conducted as follows. Air at 100 kPa and 20 degrees Celsius is compressed reversibly and adiabatically. In other words, these are our initial conditions. So P1 is 100 kPa. T1 is equal to 293 kPa. So 293 Kelvin. So it's compressed from 1 to 2. The air is heated. The air is then heated at constant volume to 1,500. The air now is heated at constant volume to 1,300. In other words, T3 is 1,500. T3, 1,100 is 2,773. Okay, so we are at point number 3. The air expands reversibly and adiabatically to the original volume. So expansion takes place here up until 4 to the original volume. So the original volume is V1 is equal to V4. And then it is cooled at constant volume up to the original pressure and temperature. The pressure ratio is 8. In other words, V1 over V2, which we call it RC, is equal to 8. Now, the first question says, calculate the following, the thermal efficiency. The thermal efficiency, we said we can use the temperatures, but we don't have what? We don't have T2, we don't have T4, so we can use that shortcut where we say the thermal efficiency of auto cycle is given by 1 minus 1 divided by compression ratio gamma minus 1. So we have everything. We have got compression ratio, it is 8, gamma is 1.4, and therefore when we substitute, we say 1 minus 1 divided by 8, 0.4, and the answer is 56.5%. This one is easy and straightforward. That is the first one. The second one, the heat input. Where does heat input okay? Between 2 and 3. So we say Q. It says per kg of air. In other words, mass is equal to 1. And because it's taking place at constant volume, it's going to be CV. It's going to be M. CV is taking place between 3 and 2. It's going to be MT3 minus T2. That's what we have. So mass is 1. CV is given here is 718. Is given. The only thing that we need to calculate here is T2. So we know that T2, that is from chapter 1, over T1 is equal to V1 over V2. You remember this formula, gamma minus 1. So we can say that T2 is equal to RC. RC is V1 over V2 gamma minus 1, which is multiplied by T1. And RC is 8 exponent 0.04 multiplied by T1, which is 293. And then T2 is 673,14 Kelvin temperature. So from here now we substitute. We say 1 multiplied by 0.718 bracket T3 2773 minus 673 14. Now Q in is equal to 789,7 kilojoules per kilogram. This is our answer number 2. Yes.
T3 is 1773, not 2773.
Oh yeah, sorry about that. Where are we? Okay, sorry. 1. Thank you. Right, but we still get the same answers. I think I made a mistake. So we have an answer for question number 2. So the net work output, so work net for the cycle. So we know that for every cycle, can be auto or any other cycle, work net, the efficiency is given by work net divided by QE. Remember the slide that I showed you, that work net is equal to, efficiency or thermal efficiency of any machine is given by work net divided by QE. So in this case here, we have the efficiency, it is 56.5%. We have Q in, it is 789. Therefore, we say work net. Oh, sorry. Work net is going to be 0.565 by 789, 7. The answer is 446,2 kilojoules per kilogram. So this is our work net. And the last one is to calculate the maximum pressure cycle. The maximum pressure cycle according to a PV diagram is P3. So what we are going to do in order to calculate P3, we are going to work in reverse. We are going to work from 3 to 2 to 1. So in order for us to get P3, so we say that P3 V3 over T3 is equal to P2 V2 over T2. But from a PV diagram, V2 is equal to V3, so they cancel. V2 cancels V3. We have T3, we have T2, but we don't have P2. How do we calculate P2? Now we must also say that we must go back to 1 again, where we say P1 V1 gamma is equal to P2 V2 gamma. Now we have P1, we have got V1, so we can say that P2 is equal to V1 over V2 exponent gamma multiplied by P1, which is P2 is equal to 8 bracket 1.4 multiplied by P1. P1 is 100. And the answer here is P2 is 1837. 1837, 92 kPa. That is P2. So from here now we say P3 is equal to P2 multiplied by T3 divided by P2 T3 divided by T2. So I don't have space here. I don't have space here. I will have to. No, I can still make space here. Okay, so we can say that P2 we have is 1837,92 multiplied by T3 1773 divided by T2 is 673,14. The answer is let's see, the answer is 4840. 4840,94 kPa, or we can say 4.84 megapascal. Before I forget, ladies and gentlemen, did you do examples on the second law in class? Guys, I'm asking you a question. Second law?
Not really that we remember. I think we did not do it.
So you haven't done the second law calculations?
Yes, sir, we did not do second law calculations.
No calculations? Yeah, that is
we have not done calculations, sir.
Yeah, that is going to be a problem because in the media test you are going to have calculations on second law. That one you cannot avoid. You cannot avoid calculations on second law. It's very, very important. Okay. Anyway, this is that's all about question one. I don't know if there's any questions, but as far as I'm concerned, this is pretty much straightforward. I mean, we didn't have to calculate V2, V3, V4. All the information is here. So when you are dealing with auto cycle, you have to expect something like this. There's nothing more than this. So this is all about auto cycle. But it is important that you draw these sketches here because they are going to guide you in terms of the values, whether the values do make sense or not. Otherwise, if you trust yourself that your values are always correct, there's no need for you to do that. But I can assure you that in the final test, please draw the sketches because when you are in trouble, at least we as lecturers, we know where to go. We know where to go. Right. So let's attempt question one of a diesel cycle. Diesel cycle. Right. An engine using a diesel cycle has a compression ratio of 20:1. Now listen to this. You remember question one, we said the compression ratio was 8 because it's petrol. So now the compression ratio is 20. In other words, V1 over V2 is equal to 20. Now the cutoff ratio is equal to 2. So the cutoff ratio is the ratio of volume at 3 to volume at 2. In other words, V3 over V2 is equal to 2. At the start of the compression stroke, the air pressure is 100 kPa and 15 degrees Celsius. And then we calculate the following. So we draw sketches, PV diagram. So the difference between auto cycle and diesel cycle is that heat input takes place at constant pressure. So we have 1 here. Between 1 and 2 is compression. Between 2 and 3, heat is added, Q in. Q in. Between 3 and 4 is expansion. And then between 4 and 1 is Q out. PV diagram. The TS diagram of Otto cycle and diesel cycle are the same. Temperature and entropy diagram. So one, 2, 3, and 4. Right, now we are done with the sketches. So the data that we have is V1. V1 over V2, which is beta. No, not beta, it's RC. Compression ratio is 20. And then we have beta, which is compression ratio. Beta, which is V2, 3 over V2 is equal to 2. Now, the first question says calculate the thermal efficiency of this cycle. Now, diesel cycle efficiency is given by 1 minus 1 divided by compression ratio, gamma minus 1, bracket. And then we have cutoff ratio to the power gamma minus 1 divided by gamma bracket compression ratio minus 1 bracket. That's what we have. And from here, we have all the information. There's no need to calculate anything. So we say that 1 minus 1 over 20.4 bracket is going to be 2. 1.4 minus 1 divided by 1.4 bracket 2 minus 1 bracket, and the answer is 64.7%. So there is no actual diesel cycle that can give you efficiency of 64.7%. So this is an ideal or a theoretical cycle. The practical one, the notes said the maximum efficiency is 40. I'm not too sure about 40, but I know that around 35, 36, 37, we can get the thermal efficiency of that much. The second question is calculate the maximum temperature in the cycle. So according to our TS diagram, the maximum temperature is T3. We are here, T3. So from T3 again, we are working anti-clockwise from 3 to 2 to 1 in order to get what we want. So we say that P2, V2 over T2 is equal to P3, V3 divided by T3. So we are looking for T3. So what else do we have here? We know that the pressure at 2 and the pressure at 3 are the same, constant pressure process. P2 is equal to P3, so they cancel each other. And then we can conclude and say T3 is equal to V3 over V2 multiplied by T2. So this is the answer for T3. V3 over V2 is given as 2, is here. So we say T3 is equal to beta multiplied by 2. So if we simplify it, that's what no. Yeah, this is nonsense, man. It's not multiplied by 2, it's multiplied by T2. Multiplied by T2. Or we can say that T3 is 2. 2T2. Now we have to calculate T2. From the previous question, we said T2 over T1 again is RC gamma minus 1. Therefore, T2 is going to be 20, 0.4 multiplied by T1 is, what is T1? T1 is 288. 288. And the answer is T1, T2 is equal to 954. 954.56 Kelvin. So T3 is equal to 2 by 954.56, which is equal to 1909. 1909.13 Kelvin. Right. So this is answer number 2. Heat input is between 2 and 3. So we say Q in. CP. Remember now, heat addition takes place at constant pressure. So it's CP, not CV. T3 minus T2. So 1 multiplied by CP. You see in this question here, R, CP and CV are not given. But because we are dealing with air, I said when we are dealing with air and that information is not given, we know that air, CP for air is 1005. CV for air is 0.718. So we say 1.005. That's some of the information that you need to know. 1.005, where's T3? T3 is 1909 minus 954. And the answer is Q in is 959. Q in is 959.34 kilojoules per kilogram. One thing that was not mentioned in this, I think, is a mistake. They did not give us the mass of air, in other words, per kilogram. So we assume that it's per kilogram. It's a mistake. That one must be given. So I apologize for that. There has to be an indication as to the mass of air. So in the previous question, they did say that per kilogram. So I think when I was typing these questions here, I forgot to say per kilogram of air. So the mass is 1. I apologize for that. So we have Q in. The last one is going to be net work output. Net work output, we have done that, we did that already. We know how to calculate that because we said that efficiency, thermal efficiency is work net divided by QE. Therefore, work net is going to be, efficiency is 0.647 multiplied by Q in. Q in is 959.34, and the answer is what? 620.7. Right, so that is the last one. And again, another easy question. So I said that this chapter is really one of the easiest chapters. Just spend time on this. Let's say homework. You must do all of them. All questions on auto cycle, all questions on diesel cycle, and all questions on dual cycle. The only thing that you have to memorize here is simple, are the efficiencies. In fact, you don't have to memorize them because we will provide you with a formula sheet in the exam. So there's no need for you to memorize questions. Okay. Yeah, now it's approaching 11 and I'm getting tired now. Let's do the last one and then we are done. I'm tired. Right. The next one is dual cycle. Okay. the next page. Right. The last question here is a dual combustion cycle. A dual combustion cycle has a compression ratio of 18. Compression ratio RC. I said dual cycle is the same as diesel cycle. It's just that heat is added twice at constant volume and constant pressure. The maximum pressure in the cycle is 9 megapascal. So we don't know whether it's P3 or P4 or P2. Let's draw the sketch. The sketch will guide us. Pressure here, volume. So one, 2, 3, 4, and 5. So heat is added at constant pressure, and also heat is added at constant volume. Q out. In the TS diagram, we have something like this. One, 2, 3, 4, and 5. So when they say the maximum pressure, it means it's P3, which is equal to P4. So P3 is equal to P4 is 9,000 kPa. And the maximum temperature is 2,000. Maximum temperature is T4. We are here. That is the maximum. T4 is 2,273 Kelvin. And then the pressure and the temperature before compressions are 115 and 25 respectively. So P1 is 115 kPa, and the T1 is 298. The first question says calculate the cutoff ratio. The cutoff ratio, V4 over V3 is the cutoff ratio. That's what they're looking for. And again, we work in reverse. Start from 4 to 3, from 3 to 2, from 2 to 1. We will say P3, V3 divided by T3 is equal to P4, V4 over T4, right? P3 is equal to P4, therefore they cancel. P3 is equal to P4, they cancel. So the question says calculate V4 over V3, which is equal to T4 over T3. So this is what we are looking for. We are looking for beta, which is V4 over V3, and then T4 is given. We have to calculate T3. And to get T3 again, we need to work in reverse. Now we are looking for 3. We will say that P2, V2 over T2 is equal to P3, V3 over T3. We are looking for T3, but we know that V2 is equal to V3. It's a constant volume, so they cancel each other. V3 cancels V3. And then T2, we don't have, but we can calculate. P3, we have, is 9,000. P2, we can easily calculate. So T3 can be calculated. Let's start with T2. We said that T2 is equal to RC 0,4 multiplied by T1. RC is 18, exponent 0,4 multiplied by 298. And T2 becomes 946, 946,95. That's the first one. P2, we say that P2 is equal to RC gamma multiplied by P1, which is 18 exponent 1.4 multiplied by P1 is 115. And then P2, we said is, what is P2? 6577, 6577,78 kPa. So we have both T2 and P2. And then now we can substitute. Now we say P3. T3 is equal to P3 by T2 divided by P2. When you substitute both, our T3 becomes 1295. 1295,66 Kelvin. And then we go back to our original formula where we say T4 is 2273 divided by 1295,66, and then our cutoff ratio becomes 1.75. 1.75. That is our cutoff ratio. The first question. The second one is the efficiency. Second one is efficiency, and I believe we have everything now for efficiency, where we say that the dual efficiency is equal to 1 minus 1 divided by RC gamma minus 1 bracket. Or we have got this guy here is called the pressure ratio. Pressure ratio beta gamma minus 1 divided by pressure ratio plus pressure ratio gamma bracket beta minus 1 bracket. So I think we have, the only thing that we don't have is the pressure ratio. So the pressure ratio, this guy here is, let's go up and see where the pressure ratio is. P3 over P2. P3 over P2. Where is P3? P3 is 9,000 divided by P2, 6577,78. So that alpha is 1.368. So that is our pressure ratio. So now we substitute. We say thermal efficiency is 1 minus 1 divided by 18, 0,4, 1.368 multiplied by beta, I think it was 2. Is it 2? 1.75. 1.75 exponent gamma minus 1 divided by 1.368 minus 1 plus 1.368 by 1.4 divided by 1.75 minus 1. This is where students struggle. For them to get the answer here is going to be a big struggle. So it's one of those things that I'm not looking forward to. So the final answer here is 65%. That is the final answer. Everything is correct here, but I know that to use your calculators to get this value, I'm telling you, it's going to be a serious problem. And the last question now is what? They want the network output. We have efficiency, we have Q in. No, we don't have Q in, but Q in, you can easily determine Q in. So Q in is going to be Q in between 3 and 4, 3 and 4, and between 2 and 3. Because Q in is placed twice in a cycle. Between 2 and 3 plus Q in between 3 and 4. So between Q and 3 is going to be M CV T3 minus T2 plus M CP T4 minus T3. So ladies and gentlemen, M is 1, CV